chapter number 1, Electrostatics. Now, electrostatics is the branch of physics that studies electric charges at rest. If the charges are at rest, then what is the behavior of all the charges? This study, and that study is done in this branch, hence it is called electrostatics. And we know what is electric charge. We know in the last semester we have seen that the structure of atom. In the atom, there are electrons and there are protons. Electrons are nothing but negatively charged and protons are nothing but positively charged. In an atom, the number of electrons, that is total charge on the electron, is equal to the number of protons, that is the total charge on the proton. Therefore, atom is neutral. Therefore, atom is neutral. And we know material or matter or any body is made up of the large number of atoms. Now, due to some incidents, there may be possibilities that there is a imbalance of electric charges, that is imbalance of number of electrons and number of protons. If there is imbalance of charges, then such a matter becomes an electric charge. That means if there are large number of electrons as compared to the protons, then what will happen? Such a matter becomes negatively charged because negative charge is more. Or if there are less number of electrons as compared to the proton, then such a matter becomes positively charged. In this way, there are positive charge and there are negative charges. Positive charges and the negative charges. Also, we know that if there are like charges, then there is a repulsive force, or if there are opposite charges, then there is a attractive force that we know. In this way, this is the concept of charges. Also, we have seen that on any matter, the minimum charge is 1.6 into 10 raised to minus 19 coulomb. This is the smallest unit of charge. Okay. And on any matter or any object or any body, the charge is always equal to plus or minus n into E, where n is the number of more electrons or protons. If there are protons, suppose there are two more protons than the electron, then charge is 2 into 1.6 into 10 raised to minus 19 coulomb in this way. Okay, the charge is said to have a discrete nature. Discrete nature means what? The charges in on the body, the charge is plus or minus Ne. Suppose if there is one charge, one electron or one proton more, then 1.6 into 10 raised to minus 19 coulomb charge. If there are two electrons or two protons, then the next charge is 2 into 1.6 into 10 raised to minus 19 coulomb. And in this way, therefore, the charges are discrete and it is said to be quantized. Okay, this much we have seen in the last or yesterday. Now we have to consider the revision of Coulomb's law. In the 8th or 9th standard, we have seen the Coulomb's law. The Coulomb's law is related with the stationary charges. If there are two stationary charges and they are separated by some finite distance r, suppose, then in between these two stationary charges, there is a force of interaction. Force of interaction means what? There may be attractive force or there may be repulsive force. This attractive or repulsive force that is given by Coulomb, hence it is called Coulomb's law, and by the name of Coulomb, it who discovered this law, hence it is called Coulomb's law. Now we have to define the Coulomb's law. The statement of Coulomb's law. This law states that the force of interaction means what? There may be attractive force or there may be repulsive force in between the charges. If there are two charges, suppose Q1 and Q2, they are separated by a finite distance r, then how much is the force of interaction between these two charges? That is given by the Coulomb's law. And this law states that The force of interaction, that is attraction or repulsion between 2 point charges at rest. Now the 2 point charges. What is point charge? That also I have explained you. Point charge means the dimension of charge is very less than as compared to the separation of these two charges. In this case, separation is r, and if the dimension or diameter of the charge is very very less than as compared to the separation r, then such charges are called point charges. The Coulomb's law is related with the point and rest charges. 2 point charges at rest, that is important, is directly proportional to the product of magnitude of charges. Product of magnitude of charges. Product means q1 and q2. These are two charges. Then product is q1 into q2. This directly proportional and inversely proportional to the square of the distance between them, that is r square. Okay, this is the statement of Coulomb's law. Again, let us consider statement. The Coulomb's law states that the force of interaction between 2 point charges at rest is directly proportional to the product of magnitude of the charges and inversely proportional to the square of the distance between them, and it is along the line joining them. The direction of force is always along the line joining them, that is from q1 to q2. This is the direction of force. Okay, let us consider these two charges q1 and q2. They are separated by some distance r, finite distance r, in the some medium. Then then the force is directly proportional to the product of magnitude of these two charges q1 and q2, and this force is inversely proportional to the distance r square, that is f is directly proportional to 1 upon r square, or f is inversely proportional to the r square. By combining these two equations, that is f is directly proportional to q1 q2 and f is directly proportional to 1 upon r square, combining these two equations we get f is directly proportional to q1 q2 upon r square. If we remove this proportionality sign, then f is equal to beta into q1 q2 upon r square, where beta is called proportionality constant and this is called a Coulomb's constant. Then we have to find out the value of beta. The value of beta is calculated by using the unit of the SI system of units, where beta depends upon the system of units. That is important. We use and the nature of the medium, which unit is used, and which medium is used, that depends upon the beta. In SI system of units, the charge is measured in Coulomb. Unit of distance, that is r, is measured in meter. Then unit of force, that is measured in Newton in SI system of unit. Now if charges are situated in the free space, medium is free space or vacuum, then SI unit, in this case, in this situation, that is the system of unit is SI and charges are situated in vacuum, then the value of beta is 1 upon 4 pi epsilon 0. This is the value of beta in SI system of unit and in the free space. That is beta is equal to 1 upon 4 pi epsilon 0, where epsilon 0 is called permittivity of free space. That is the capability of that particular medium, how much charges are stored. Epsilon 0 is permittivity. Permittivity means what? Permittivity याचा अर्थ असा होतो की that medium is what? Air or vacuum. How much charge that can store? This is called the permittivity. Okay, this permittivity is epsilon 0. Thus Coulomb's law in free space can be expressed in SI system of unit using equation number 2 and 3, that is f is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square. Then this 1 upon 4 pi epsilon 0, this value is calculated by using all these constants. 4 is constant, pi is constant, and epsilon 0 is also constant. For air, this epsilon 0 is 8.854 into 10 is to minus 12 coulomb per Newton meter square. Using all these values, we get 1 upon 4 pi epsilon 0 is equal to 9 into 10 raised to 9 Newton meter square per Coulomb square. This is the value of beta. This value of beta is used to find out or to calculate or to solve the problems. If the charges are situated, in other case, if the charges are situated in some medium, in previously we have considered the charges are situated in the air or vacuum. Now, if the charges are situated in some medium, then the Coulomb's law can be written as F is equal to 1 upon 4 pi epsilon. Instead of epsilon 0, we can write epsilon 1 upon 4 pi epsilon q1 q2 upon r square. That is the same. Okay, only the change is that instead of epsilon 0, we are using here epsilon, where epsilon is the permittivity of medium, which medium we are using. It may be a water medium, suppose. It may be a glycerin medium, suppose, or any other medium. For that particular medium, the value of epsilon is different for different medium. That epsilon is used. Okay. Then F is equal to 1 upon 4 pi epsilon Q1 Q2 upon R square. This is equation number 5. Now using equation above, that is 4 equation and 5 equation, we have to define one more quantity that is called a dielectric constant. Now the ratio of permittivity of medium, any medium, that is epsilon, to the permittivity of free space or vacuum, that is called a dielectric constant, and this K is equal to epsilon divided by epsilon 0. Epsilon divided by epsilon 0, this is called a dielectric constant. This is a constant. This is a constant because unit of epsilon and unit of epsilon 0 is same, then this is a constant. Then by using this equation, we can take epsilon is equal to k epsilon 0. Using this value of epsilon into equation 5, we get one more equation, that is F is equal to 1 upon 4 pi k epsilon 0. Value of the epsilon is k epsilon 0 into q1 q2 upon r square. This is equation number 6, and this equation number 6 is a general form of Coulomb's law. This equation can be used to any medium. Okay, if the medium is suppose air, then value of epsilon 0 is 1. Value of k is 1. Value of k is 1. F is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square. That is, this equation becomes equal to the equation for Coulomb's law equation for vacuum or free space. If any medium, then other medium, the value of k is always greater than 1. Okay, for air or vacuum, k is equal to always 1, and for any other medium, it may be water medium, it may be glycerin medium, or it may be any other medium, the dielectric constant k is always greater than 1. Then this equation is used for any medium. The equation 6 is what? The general form of Coulomb's law. General form of Coulomb's law. If we use equation F is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square, then this equation is only valid for vacuum or free space. If we use equation, suppose F is equal to 1 upon 4 pi epsilon q1 q2 upon r square, this equation is valid only for any medium. But if we use equation F is equal to 1 upon 4 pi k epsilon 0 q1 q2 upon r square, this equation is valid to any type of medium. It may be vacuum, it may be air, it may be any other medium. This is a general form of Coulomb's law. This is a general form of Coulomb's law. Okay, now then we have to consider the vector form of Coulomb's law. Okay, this is the equation 6 is nothing but the Coulomb's law in a scalar form. There is no any vector quantity. There is no any vector quantity. But in this case, what happens? F is a vector quantity. Q1, Q2, that is charges are nothing but scalar quantities, and R is a vector quantity. That is the displacement. R is vector quantity, F is vector quantity. Then we have to consider this equation in vector form also. Then we have to consider this equation in vector form. To write this equation in vector form, we have to consider some notations. Okay, to write Coulomb's law in vector form, let us use the following notations. If there are two charges q1 and q2, they are separated by some finite distance r, then we have to consider some vector notations. We have to consider some vector notations. Now, if we consider the force is a vector, we know, then F bar 1, 2, that is the vector. 1 indicates charge q1 and 2 indicates charge q2. Then F12 bar is nothing but force acting on charge q1 due to charge q2. F12 bar means what? The force acting on charge q1 due to charge q2. Similarly, F21 bar is equal to what? The force acting on charge 2, that is q2, due to charge the q1. This is called F21 bar. Similarly, R12 bar, that is the displacement measured from charge q1 to q2. q1 पासून q2 पर्यंत डिस्प्लेसमेंट मेजर केलं, that is called R12 bar. Then R21 bar, that is the displacement measured from charge q2 to q1, that is q2 to q1. Similarly, the unit vector R12 cap, this is a unit vector in the direction of R12 bar vector. Similarly, R21 cap is nothing but unit vector in the direction of R21 bar. And R is the distance between the two charges, that is the magnitude of displacement, R distance between the two charges, that is R is equal to mod of R12 bar, that is the magnitude of R12 bar, or is equal to magnitude of R21 bar. These notations we have to use if we want to convert this Coulomb's law in a vector form. Okay, now here we have to consider this vector form of Coulomb's law in two ways. In first way, we consider like charges, and in second way, we consider unlike charges. In case of like charges, we know there is a repulsive force, and in case of unlike charges, there is a attractive force. Now we have to consider these two cases. Let us consider the first case, that is the electric force between two like charges. If there are two like charges, plus q or minus q, किंवा plus q1 plus q2 or minus q1 minus q2. These are the like charges. These like charges q1 and q2, they are separated by a distance r. In between these two charges, there is a repulsive force. If we consider the force exerted on charge q1 due to charge q2 is F12 bar, the direction of F12 bar is in this way. Similarly, if we consider the force exerted on charge q2 due to charge q1, the F21 bar is in this direction because there is a repulsive force. Repulsive force असल्यामुळं F12 bar and F21 bar, they are oppositely directed. They are oppositely directed. Then R12 bar is the displacement measured from charge q1 to charge q2, and R21 bar is the displacement measured from charge q2 to charge q1. Okay, now using this figure, we have to write Coulomb's law in vector form in first case. Okay, the magnitude of force acting on charge q1 due to charge q2. सुरुवातीला आपण F12 बार बघूया and then F21 बार विचारात घेऊया. F12 bar means what? The force exerted on charge q1 due to charge q2. Therefore, it is called, the magnitude of this force is F12. That is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square. Okay, this equation 1 is written in a vacuum or free space medium, where epsilon 0 is permittivity of free space, that we know. Okay, F12 bar and R21 bar from the figure. F12 bar and R21 bar, they are in the same direction. So F12 in vector form can be written as, this equation 1 we have to write into the vector form. वेक्टर फॉर्म मध्ये लिहायचं म्हणजे काय करायचं, F12 बारच्या डोक्यावरती एक रेषा काढायची म्हणजे वेक्टर काढायचा, आणि राईट हँड साईडला युनिट वेक्टर मल्टिप्लाय करायचा इन द डायरेक्शन ऑफ वेक्टर R21 बार. ओके, दिस इज द इक्वेशन. This is the equation number 2, that is F12 bar is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square into R21 cap. This is unit vector in the direction of R21. आता इथं R21च का घेतलेला आहे, because R21 and F12 are in the same direction म्हणून हे लक्षात घ्या. F12 बार फिगर पुन्हा दाखवतो मी बघा. इन द फिगर F12 बार and R21 bar, F12 bar and R21 bar, they are in the same direction. They are in the same direction. That's why the unit vector is taken along R21 bar. Then equation 2 can be written as F12 bar is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square r21 cap. This is a unit vector in the direction of r21. इथं r21 का घेतला हे लक्षात घ्या. r21 आणि f21 they are in the same direction, where r21 cap is unit vector along r21 bar. That is most important. Then by definition of unit vector, r21 cap is equal to r21 bar divided by magnitude of r21. That is as usual. This is the definition of unit vector. That is equal to r21 bar divided by magnitude of r21 is r. ते आपण सुरुवातीलाच बघितलेले आहे. Therefore, equation 2 becomes f12 bar is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r cube into r21. Okay, r21 bar, equation number 3. Similarly, force exerted on charge q2 due to charge q1 can be written as, आता या इक्वेशन 3 मध्ये चेंजेस करून आपण similarly force exerted on q2 due to charge q1 can be written as f21 bar is equal to 1 upon 4 pi epsilon 0 as it is, q1 q2 upon r cube as it is, only the change is r12 bar here. Okay, because r12 bar and f21 bar they are in the same direction. फिगर मध्ये पुन्हा बघा तुम्ही, फिगर मध्ये पुन्हा बघा, r21 bar आणि r12 bar they are in the same direction. Then equation number 4. If we compare equation 3 and 4, it is clear that r12 bar is equal to minus r21 bar. Minus r21 bar means the magnitude is same but direction is different, opposite. And therefore f12 bar is equal to minus f21 bar. या इक्वेशन वरनं काय आपल्याला समजतंय की f12 bar is equal to minus f21 bar. फिगर मध्ये पण आपण दाखवलेलं आहे. Similarly, in case of the electric force between two unlike charges, if we consider q1 and q2 unlike charges, unlike means what? q1 is positive and q2 is negative, or q1 is negative and q2 is positive. They are unlike charges. If we consider unlike charges, then between unlike charges there is attractive force. Therefore, force f12 bar means force exerted on charge q1 due to charge q2 is in this direction, and force exerted on charge q2 due to charge q1 is f21 bar is in this direction. These two forces are facing towards each other because they are equal and opposite. Distance between q1 and q2 is r. Then displacement measured from q1 to q2 is r12 bar, and displacement measured from q2 to q1 is r21 bar. In this case, try to understand f12 bar, direction of f12 bar and direction of r12 bar is same. Similarly, direction of f21 bar and direction of r21 bar that is same. या ठिकाणी या दोन गोष्टी महत्वाच्या आहेत. पहिल्या केसमध्ये f12 bar आणि r21 bar they are in the same direction, but in this case f12 bar and r12 bar they are in the same direction. हा दोन्ही मधला फरक आहे, हे लक्षात घ्या. Then again, force exerted, magnitude of the force exerted on charge q1 due to charge q2 is f12 is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square. This is equation number 6. This is magnitude as usual by using Coulomb's law. Okay, now this from figure 2, f12 bar and r12 bar are in the same direction. Then equation 6 can be written in vector form as f12 bar is equal to 1 upon 4 pi epsilon 0 q1 q2 upon r square into r12 cap. r12 cap का लिहिलं आपण? Because r12 and f12 they are in the same direction. r12 cap is the unit vector in the direction of vector r12. Then by using definition of unit vectors, r12 cap is equal to r12 bar divided by magnitude of r12 bar, and that is can be written as r12 bar upon r. Using this value in above equation, we get F12 bar is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R cube into R12 bar. This is equation number 7. Similarly, we can write force exerted on charge Q2 due to charge Q1 using equation 7. F21 bar is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R cube into R21 bar. इथं फक्त R21 बार आपण चेंज केलेला आहे बिकॉज R21 बार and F21 bar are again in the same direction. Now using equation 7 and 8, it is clear that R12 bar is equal to minus R21 bar. Therefore F12 bar is equal to minus F21 bar. या ठिकाणी सुद्धा F12 bar आणि F21 bar, they are in the equal and opposite direction. Then by considering these two equations, equation number 5 and equation number 9, these two forces in first case and in second case also, they are equal and in opposite direction. Okay, then by observing equation 5 and 9, it is clear that, or it is concluded that whenever two charges are facing each other, these charges experience equal and opposite directions. Okay, by observing equation 5 and 9, it is concluded that whenever two charges are facing each other, okay, these charges experience equal and opposite force. आपण पहिल्या केसमध्ये पण बघितलं, ए केसमध्ये आणि बी केसमध्ये पण बघितलं. Okay, now by observing all these things, we have to consider some conclusions of this Coulomb's law. Following observations can be noted in connection with the Coulomb's law. The force between two electric charges, number 1. Coulomb's law मध्ये ह्या काही ज्या गोष्टी आहेत, that is important. Coulomb's law is strictly applicable in case of point charges at rest. मी या अगोदर तुम्हाला पॉइंट चार्ज म्हणजे काय हे सांगितलेलं आहे, and these are the at rest. That is important. Point charges at rest. While dealing with force between charges in motion, we have to modify the expression. जर आपल्याला मुव्हिंग चार्जेससाठी कुलम्स लॉ लिहायचा असेल तर काही मॉडिफिकेशन्स करायला लागतील. ओके, आता तरी आपण फक्त रेस्ट चार्ज संबंधीच बघतो आहोत. नंबर 2, दिस लॉ होल्ड्स गुड ओव्हर द वाईड रेंज फ्रॉम 10⁻13 मीटर टू मेनी किलोमीटर. म्हणजे दोन चार्ज मधलं अंतर किती असावं, तर मिनिमम अंतर 10⁻13 मीटर असावं आणि मॅक्सिमम मेनी किलोमीटर्स पर्यंत चालेल. देन दिस लॉ होल्ड्स गुड. ओके, the distance less than 10⁻13 मीटर it breaks. आपल्याला योग्य रिझल्ट मिळू शकत नाही because less than 10⁻13 meter the nuclear forces are exist and therefore this Coulomb force may be disturbed. Okay, 10⁻13 मीटरच्या आतमध्ये जर दोन चार्जेस येत असतील तर न्यूक्लिअर फोर्सेस त्यामध्ये ऍड होतात आणि न्यूक्लिअर फोर्सेस ऍड झाल्यामुळं ॲक्च्युअल कुलम फोर्सची व्हॅल्यू कॅल्क्युलेट करता येत नाही. दिस इज द मोस्ट इम्पॉर्टंट थिंग. देन नंबर 3, दिस फोर्स इज अ सेंट्रल फोर्स. सेंट्रल फोर्स मीन्स the force is acting along the direction of line joining these two forces. Along the direction of line joining these two forces, hence it is called the central force. म्हणजे Q1 आणि Q2 हे दोन फोर्सेस चार्जेस जर असतील तर फोर्सची डायरेक्शन Q1 पासून Q2 पर्यंत असेल, Q1 पासून दुसरीकडे डायरेक्शन नसेल किंवा Q2 पासून दुसरीकडे डायरेक्शन नसेल. दॅट इज कॉल्ड अ सेंट्रल फोर्स. नंबर 4, द फोर्स बिटवीन टू चार्जेस इज नॉट अफेक्टेड बाय द प्रेझेन्स ऑफ अदर चार्ज. सपोज दोन चार्जेस प्रेझेंट असतील आणि त्यांच्यामध्ये जो काय फोर्स एक्झर्ट होत असेल, जर आपण तिसरा चार्ज त्या ठिकाणी नेला तर तिसऱ्या चार्जमुळं कोणत्याही प्रकारचा इफेक्ट त्या फोर्सवरती होणार नाही. दिस इज द मोस्ट इम्पॉर्टंट थिंग in case of Coulomb's force. Okay, now let us stop here. We have completed definition of Coulomb's law and the vector form of Coulomb's law. Okay, now let us stop here and next time we will continue.